Welcome to our very first Amplify Science 8th grade unit, Harnessing Human Energy. My name is Iman. I'm currently in school leadership and former 5th through 8th grade science teacher here in sunny San Francisco, California. In this unit, students assume the role of energy scientists and take on this question. How can rescue workers get energy for their equipment during rescue missions? Before we begin, go ahead and take out the following 3 items. So why does harnessing human energy matter? Not only is energy at the forefront of conversations within American politics as well as the scientific community, this unit exposes students to the different types of energy systems that exist in our world and also allows you as the teacher to establish strong systems and routines in your classroom. This is a great opportunity for students to learn how to use Amplify Science as well as think about the different systems they'll encounter throughout the year, from usage of the sim, annotation of scientific texts, as well as scientific argumentation. Chapter overviews. Our Chapter 1 question is, what is energy and why does it matter to the rescue team? In Lesson 1.1, students are introduced to their role as energy scientists. They learned that rescue workers have a huge problem when it comes to sustaining energy, especially when their mission brings them to remote places. Students use the sorting tool for the very first time, and they're challenged to think about what is energy and what has it. They also get their first look at the sim, where they begin to explore different types of energy systems. In Lesson 1.2, students are introduced to scientific argumentation, which follows a model that they'll use throughout the rest of their Amplify units. They also have their first Amplify hands-on investigation of the school year, and they ultimately learn that energy is the ability to make something move or change. In Lesson 1.3, teachers do a small teacher demonstration using some toy wind-up shoes, and they learn that when something is moving, it has kinetic energy. And when something has the ability to make things move or change in the future, it has potential energy, even if it's not moving or changing now. In Lesson 1.4, students are introduced to what it means to be an active reader of scientific texts while learning about energy inventions. They learned that engineers have created devices that convert energy from the sun or energy from the human body to electrical energy that can be stored in a battery. This is a really important concept that students are going to tap into on later lessons as they begin to hypothesize how to get energy to the emergency workers when they need it. Moving right along to Chapter 2, our question is, how can the rescue workers get energy to the batteries in their equipment during rescue missions? In Lesson 2.1, students get to plan an investigation using the sim to explore 3 claims. How do objects get energy? And ultimately, they learn that energy can move from object to object. They're also introduced to a key vocabulary word, which is a generator, a machine that converts kinetic energy to electrical energy. In Lesson 2.2, students read an article and learn that there are different types of energy that have their advantages and disadvantages. They also learn this important concept that energy can't be created or destroyed. It simply just transfers. They work in group to analyze the energy source cards and deliver a recommendation to the rescue workers on their best source of energy. In 2.3, students get to write a scientific argumentation on their energy system recommendation, which we'll also use for our Chapter 2 task. Using the evidence cards from 2.3, go ahead and give our chapter focus task a try. For this Chapter 2 task, students could have picked Claim 1 or Claim 2. What's important is how students are elaborating and connecting their evidence card to the claim that they chose. And here is our rubric, focusing heavily on the elaboration and reasoning piece. For our final chapter in this unit, students are asking themselves, what is the best way for rescue workers to capture energy from their body's motion during rescue missions? In Lesson 3.1, students are given another article, and they learn that electrical energy can be stored in a battery as potential energy so it can be used later. In this article, students also get to review each type of energy transfers that occur in various systems. They assess whether or not it's a good option for the rescue workers, and they begin designing their own energy systems. In Lesson 3.2, students learn that energy systems can also be represented in drawings and diagrams as well as physical models. And in a group, they create a model and diagram for their own energy system design. And finally, in Lesson 3.3, students focus on the reliability of evidence after they're presented with a new problem. A school principal is interested in saving money on their school's energy costs by capturing energy from students' physical activities while they're at school. There is one formal assessment in this entire unit, and that's our optional 3.4 end of unit assessment. Go ahead and give this one a try. And here is our exemplar response for this one. Throughout this entire launch unit, you should be thinking about what systems and routines are you going to incorporate in your classroom to set you up for success for the entire year. For example, computer usage. How are kids going to be storing their computers, logging into Amplify, as well as getting them used to navigating the site? In terms of materials, are students going to be using folders, notebooks? Are you going to provide packets or daily worksheets? And also passing out materials and feedback. How often is that going to happen? In terms of turning in materials, is that something you're going to do daily, weekly, or even monthly? And also, let's get students excited. Think about how you're going to get students to invest. How are you going to track their progress from exit tickets, class trackers, individual trackers, or maybe even celebrating their progress? This is an exciting unit to really establish strong culture and systems in your room in a way that's engaging for kids. Thank you, teachers, and I hope you all have an amazing school year. Final steps for our KIPP teachers. Go ahead and complete steps 1 through 7. And remember, this is all for the love of science.